I'm sorry, excuse me. All right, guys. Day 6 notes. You might remember of learning this back in middle school. It's been a minute though. And if you don't, that's totally okay too. So we're just going to talk about it from the top. So we're going to come back and revisit similar figures, right? Which we've keep coming back to ever since Unit 4. So just as a little reminder, remember similar figures like these guys right here, right? Similar figures always have corresponding angles that are congruent, and their corresponding sides are proportional. Now, the proportionality is the main thing that we're going to be talking about today. Knowing about congruent angles is really just there to prove that you have similar figures, but so we're mostly going to be talking about the proportionality. So we've talked about this before, that all similar figures have a multiplier, right, that we refer to as the scale factor. Right, so, or your dilation factor, if you want to think about it that way, right? So your scale factor, so I know if I see a scale factor of 2, then that means all the side lengths of my larger similar figure are twice as long as the original. Or vice versa, if my scale factor is a half, then the side lengths are all half as long as the original figure, right? We're also going to be referring to scale factor as side ratio or similarity ratio. All those words are kind of synonyms to each other. And the cool thing about that is they all start with an S. So that is going to be very favorable for us here in just a few minutes. That scale factor, side ratio, similarity ratio, they all start with an S. Okay. So we're going to do a quick little activity to remind ourselves how we need to treat proportional side lengths when it comes to not only side length, but also perimeter and also area, because now we're actually starting to get into 2D shapes, which means we've been talking about area for the last couple of weeks. And so now we're going to see how that alters when our shapes are similar to one another. Okay, so we're going to run through this quick little activity. So it says, what is the scale factor of A to B? Okay, so obviously A is the smaller rectangle, B is the larger one. So we just need to pick a pair of corresponding sides. I'm going to pick the 10 to 15. You're more than welcome to use the 16 to 24. It really doesn't matter. So I know I can make a ratio of A to B of 10 to 15. And of course, we always reduce. So our scale factor would be 2/3. Okay. Which means our original figure is 2/3 the side length of the new guy, right? Remember, scale factor is always new to old. All right, so now we're going to alter our rectangles a little bit and see what happens. Okay, so here we go. It says, what is the perimeter of rectangle A? All right, well, remember, perimeter means to add up all the sides, right? So rectangle A would be 10 plus 16 plus 10 plus 16. So that's going to give us 52. And then we're going to do the same thing with the perimeter of rectangle B. And so we have, what is that, 39, and then times 2, so 78. And now what I want to do is I want to make a ratio. So instead of doing scale factor, which again, remember, scale factor is the same thing as side ratio. They both start with S, right? But now we're making a perimeter ratio of A to B. So I'm going to go down here. So the perimeter ratio would be 52 to 78, right? And then I'm going to reduce that fraction. And what do you know? It gives us 2/3, right? So what we're taking away from this is our side ratio was 2 to 3, but our perimeter ratio ends up also being 2 to 3. And I hope that makes perfect sense, because perimeter is just the addition of all the sides. If I wanted to, you don't have to write this down. If I wanted to, you can kind of think about as perimeter as one giant side length, right? Because if I wanted to, like, let's imagine there's like a lock right here on this little corner, right? But I wanted to unlock the rectangle. And so then all 4 sides would just kind of flop down, right? And you would have like your 10, and then you'd have your 16, and then you'd have your other 10, right? And then you'd have your other 16, right? So imagine if we unlocked one of the corners of the rectangle and just let it flop open, right? It's going to just create this one long giant side length, which is the perimeter, right? So our side ratio will always be the same as the perimeter ratio, because it's all still just side lengths. We're just adding them all up. So we're still in 1D. We're still in one-dimensional land, right, when we calculate perimeter. So in the little what do you notice box, I'm going to write that the perimeter ratio is the same as, just going to underline that, the perimeter ratio is the same as the side ratio, aka scale factor. You could also write scale factor right here if you want to. All right, so the perimeter ratio will always be the same as the side ratio, right? Between two similar figures. Of course, this is only true of similar figures. If I had two totally, random rectangles or triangles or whatever shape, then that wouldn't be true unless they were similar. And again, I'm going to kind of put that reason here. It's because perimeter is a one-dimensional measurement, right? We're just adding length. We're just adding them all up, but it's still just finding length. Okay? All right, now we're going to go look at the area of the rectangles. Okay. So rectangle A is 10 by 16, which means he has an area of 160. Rectangle B is 15 by 24, so the area would be 360. So now if I make a ratio of the areas, right, it'd be 160 to 360. And if I put that in my calculator or just reduce it by hand, you are going to get 4/9 because we can reduce by 40 on the top and the bottom. So we get an area ratio of 4/9. Well, let's compare that to the side ratio or the perimeter ratio. Right, for those we got 2/3. Here we got 4/9. Well, what do you notice? Well, we just squared everything, right? And I'm hoping that makes perfect sense because every time we write the area of an object, when we put units on it, no matter what those units are, they're always units squared, right? And the reason why it's squared is because now we're in 2D land, right? And when you're in two-dimensional land, by calculating the area, right, now everything gets squared. All those ratios get squared, okay? And that's what we're noticing here about our area. So I'm going to write down, hold on, I'm not writing in highlighter. There we go. So we are noticing that the area ratio is the square of the side ratio. Or you could put perimeter ratio since they're one and the same, like we just learned a second ago, right? It's the square of the side ratio. And of course, the reason for that is because now we're in 2D space, right? And not just doing 1D calculations because we're not just finding lengths, right? Now we're finding area, like how much space does it cover, okay? Now, in order to keep these two rules straight, which they're not very difficult to forget, but we're gonna set up what we call a SPA chart. Now, am I gonna force you to use a SPA chart? No. Do I highly suggest it? Yes. Most students that miss these questions on the test, because I'm going to tell you right now, most students, when we take the test over Unit 6, they either get all of these questions correct or they get all of these questions wrong. And the majority, almost all, of the students that miss the questions do it because they don't create a SPA chart, which takes like 5 seconds of time, but it organizes all of your dimensions and gives you all of those numerical changes in a lovely chart form so that you don't forget what you're doing, okay? Because most people don't take into account dimensional change. Okay, so here we go. So scale factor, notice it starts with an S. That's the S part of SPA. And then P is perimeter. And then A is the area, right? So that's why we call it a SPA chart. Just a heads up, in Unit 7, when we add three-dimensional figures, we will add a V column and we'll call it a SPAV chart when we get to Unit 7, okay? All right, so of course, if I said our scale factor was A to B, whatever those numbers are, I know that that my perimeter ratio is going to be the exact same thing. We just discovered that in that little activity on the first page. But we know our area ratio is going to be A squared over B squared, right? Everybody gets squared when we go up a dimension. And that's what these little arrows are for. So you'll notice this first set of arrow, the blue arrow along the top, he's starting here. Notice he's right smack dab in the middle because this is where all the 1D stuff is, because scale factor and perimeter is all talking about one-dimensional stuff. And then we're hopping over to area, which is 2D. And so I know that I'm going to square to move up a dimension. And then what do you think we do to move back a dimension? We square root. Right, so it just kind of depends on which dimension you're starting with, right? If you start in 2D, then you square root to get back to 1D, right? If you're in 1D, you square to hop up to 2D. And that's really all we're learning today, right? Is just making sure that you pay attention to what dimension you're working in, okay? So let's just go run through some problems here. It says 2 triangles are similar. Yay, I need to know that in order to actually use a SPA chart. As soon as I see the word similar, I'm gonna set up a SPA chart. Again, takes 2 seconds. Just write the word SPA, make 3 columns. It says the ratio of the areas is 25 to 64. Okay, so they're telling me the area ratio, so I'm going to put him in the A column. And then he wants to know what the scale factor is. So that means we're going to want to go back to 1D land, which of course means I just need to square root. So I know the square root of 25 is 5, and the square root of 64 is 8. And voila, I'm just gonna box that column, and that's perfectly fine with me. If you wanna write out a little sentence that says the scale factor is 5/8, you can, or just circle or box that column in your SPA chart that you want me to look at. And it's really that simple. Now, obviously, we're gonna be doing more steps here in just a second, but for right now, we're just gonna set up or practice setting up the SPA chart, okay? All right, let's do it up. Here we go. 2 trapezoids are similar. Yay, SPA chart. Here we go. It says the perimeter ratio is 3 to 4. Okay, so I'm going to put the 3/4 in the perimeter column. And then it says, what is the ratio of their areas? Okay, well, I'm obviously going up a dimension to go from P to A, or perimeter to area, which means we need to square. So that becomes 9/16. Voila. Just box it. There's our answer. That would be the ratio of the areas. Okay, all right, let's hop down here. It's the same exact question. It's just giving you the information in the picture. So here's my SPA chart. So they're obviously giving us the areas, right? The area ratio is 50 to 8. Right, so I'm going to put that over here. And guys, I don't care which number you put on top or which number you put on the bottom. You do need to make, here in a few minutes when we actually get to problems that require a little bit more work, you will need to make a mental note that, oh, I'm doing big compared to small, right? So the big information is in my numerator and the small information is in my denominator, okay? But right now it just says, what is the perimeter ratio? So I basically just want to know what ratio would go here. Well, that means I'm going back a dimension from area, which means I need to square root. Now, obviously 50 and 8 are not perfect squares, right? So there's 2 things you could do here. Number 1, you can always reduce the 50 over 8 because clearly we can take a 2 out of each of those. So that will give me 25/4. And I could write that totally in place of the 50 over 8. And those are perfect squares. So when I go backwards, I know I'm just square rooting the 25 and the 4. So my answer is 5/2, right? Or if you don't want to reduce the fraction, I'll put or, you could just go ahead and square root the 50 and 8 as is. And that would give you 5√2 over 2√2. And of course, the √2's would cancel, leaving you with 5/2, right? So either way, I don't know, most people just reduce and then square root. We're pretty much always going to give you guys nice friendly answers or friendly numbers to square root and stuff, so you don't have to worry too much about it. All right, let's throw one more in the mix here. SPA chart. So again, they gave me the areas, so I'm just going to do a ratio. I'm going to do 12 to 27. You could also do 27 to 12. So just be aware when on your answer key, if your answers are the reciprocated version of my answer, then that's okay. Now 12 and 27 are not perfect squares, but 12/27 does reduce by 3 to 4/9. So I automatically know I can take the square root of that and just get 2/3 for my perimeter ratio. Again, I don't know what their perimeters are, right? I have no idea I don't even know what the side lengths of these triangles are, and I don't care. I just need to know that their perimeters would be in a ratio of 2 to 3. Okay, that's really all we're concerned about today. All right, let's go do an actual problem though, where we have to do some math, right? So number 4 says, if the perimeter of the larger figure is 15, what is the perimeter of the smaller figure? Okay, so notice once again, first of all, I don't even know what shape this is, right? It's like some weird like raindrop shape, which does not have an area formula that we know of, right? And so I can't really like use the area formula and work backwards to find side lengths like I might do for like a triangle or something like that. So the fact that it says we are going to assume that they are similar figures. It should have said that in the problem, by the way. It should have said the two figures below are similar and then kind of continue on with the problem. But what we're going to do is we're going to make our SPA chart, and I'm going to fill in all the information, right? So they told me the area was 18 to 8. Okay, so I'm going to write that into my area, 18 to 8. Again, I'm making a mental note that I'm doing big to little, just so you know. I am going to go ahead and reduce that because it does reduce to 9/4, which of course makes it very easy for me to go back and square root to hop back to one-dimensional land. And I know that the side and perimeter ratios are both 3/2. Now, why did I do this? Well, because now I can set up a proportion. Because they're similar figures, right? Everything is going to be proportional. So it said, if the perimeter of the larger figure is 15, okay, I'm going to put the larger figure on top because I did large to small. What is the perimeter of the smaller figure? I don't know, right? So 15 over x. And then because we're talking about perimeter, I have to make sure I use the perimeter ratio. So whatever you're talking about in the proportion that you're setting up, you have to make sure you use that ratio dimension. So even though it gave me the areas of 18 to 8, I can't put area ratios in a perimeter problem, right? They don't match, right? You have to use the same dimension when you're setting up a proportion. So if you try to mix and match perimeters and areas, it's not going to go well, right? Because you're talking about a problem in totally different dimensions, right? So I'm going to put that 3/2 in my other fraction. And voila, we've got this nice, easy proportion. We can just solve that in our head, right? Because when we cross multiply, we're going to get 3x equals 30. So x equals 10. So the perimeter of the smaller figure is 10 meters. Now, I'm sure most of y'all could have figured that out, right? Because you're like, okay, it's 3 to 2, but I still want to see that proportion because are the numbers always going to be super friendly like that? No, right? So we want to make sure that we are getting that proportion set up so we can see how that 10 meters comes about, okay? All right, we're just going to do this a few more times. That's pretty much it. So number 5 says the ratio of the areas of two right triangles is 4/9. Okay, again, I am assuming these are similar right triangles. It should say that, but I don't know why it doesn't. Anyway, so here's my SPA chart. It says the area ratio is 4 to 9. Okay, and I'm just going to go ahead and fill in my other two columns because it takes less than a second, right? I know I'm square rooting to go back a dimension, so those have a ratio of 2/3. All right, now I can start setting up my proportion. It says if the length of the hypotenuse of the larger triangle, now I do want to notice that I am doing big to small, right? You need to make that mental note like I was talking about earlier, right? If you're smaller, why did I just write big to small? I'm so sorry. Small to big, right? Because if your smaller number's on top, then he goes with the smaller triangle, right? And bigger number on the bottom. So when it says the length of the hypotenuse, and remember the hypotenuse is just a side length, right? So the hypotenuse of the larger triangle is 48. What is the length of the smaller hypotenuse? So that's going to give me x over 48. And then, of course, which ratio do you think I'm going to plug in? Well, I'm talking about side lengths, so I should be using the side ratio, right? I don't know what the side lengths are of the other hypotenuse, but I know it has to be in a 2 to 3 ratio. Because that is what my SPA chart is telling me, right? Because we're square rooting that 4/9 to go back a dimension. And then from there, it's just an easy cross product. All right, so 3x equals 96. So x equals 32. And I'm just going to put units because it didn't really specify anything else. Okay. All right, got a couple left here. Example 6, find the area of the shaded figure. All right, I'm going to set myself up a SPA chart. And then I'm going to ask myself, well, what ratio do I know? Well, if you look at your diagram, the only ratio I actually have enough numbers to complete a ratio for is the side lengths of 14 to 20, right? So I'm going to put 14 to 20. Now I really don't like 14 to 20 because I can reduce that to 7/10. So if you can make your numbers smaller and easier to work with, then I would totally suggest that, which means our perimeter ratio will also be 7/10, which means our area ratio is going to be 49 to 100. Right, we got to hop up a dimension there. All right, sorry, I'm gonna move this down here. Actually, I'm gonna put it right here. Sorry. All right, and then it says find the area of the shaded figure. Okay, well, I'm gonna set up a proportion. Again, I know this one's not too hard to do just in your head, but I'm still gonna set up the proportion. So let's see, clearly when I set up my SPA chart, I did big, oh my God, I just did it again. I'm doing small to big. I'm always thinking a step ahead, sorry. So small to big. So when I'm looking for the area of the shaded figure, which is the small one, I know he's gonna go on top. Right, so x over 400, right, because his area is what I'm looking for. And then, of course, if I'm setting up an area proportion, I better use the area ratio. So whatever that missing area is, I don't know what, but he better be in a ratio of 49 to 100. Right, and that would be our proportion, right? Everybody's in 2D land because we're talking about area. Right, and so what are we going to get there? 100x, right, equals 400 times 49, so 19,600. So obviously if we divide by 100, we're going to get 196. And it is an area of inches squared. All right, so this is pretty much all we're doing today, right? We're just setting up proportions. Right, just making sure that every ratio in your proportion is coming from the same dimension. All right, last one. The perimeter ratio for two similar octagons is 3 to 2. Okay, SPA chart. Perimeter ratio, 3 to 2. I'm just going to go ahead and fill in all the columns. Right, so our side ratio, of course, will always also be 3 to 2. And our area ratio is 9 to 4. So now everybody's there just waiting for me no matter what I need. All right, the larger octagon has an area of 75. Okay, again, noticing our big number is in the top and our smaller numbers on the bottom. So when I set up my proportion, I want to make sure everything is big to small. And we're talking about area, so the larger octagon is 75. What is the area of the smaller one? So 75 over x. And of course, since we're talking about area, we have to make sure we're using the area ratio, which has to break down into a 9 to 4 ratio. And there you have it. So we're going to end up getting 9x, oops, sorry about that, equals 300. Right, and 300 divided by 9 is not going to give us a friendly decimal, right? It's going to be repeating. So we're just going to leave that as 100 thirds. Right, and they did tell us it was square inches, so I'm going to make sure I add my label. The labels are even almost more important on this homework than the other ones because I need to know that you know like what dimension you're actually in for your final answer, right? Where are you finding side lengths? Where are you finding perimeter? Where are you finding area, right? And those units are really going to help determine that, okay? All right, as I scroll, it's all blank down there. All right, so that is our last day of Unit 6, right? Just dimensional change. So remember, anytime you see any word, if you see the word similar anywhere in this unit, right, it's going to be a SPA chart question. So just take the extra 5 seconds, set up the SPA chart, and then that way it's just that visual reminder, right, that you need to make sure that you're pulling out the correct ratio based on what dimension you're working with in the problem. Okay. All right. I hope that makes sense. If you're having any troubles, just shoot me an email or come in for tutorials and I'd be more than happy to help you out. All right. Bye, guys.